Assalamualaikum and hi, we are from Group 4 for Power System Engineering Simulation Assignment. So this is my group members, Ibrahim Hassan, Nurun Haidah, Hujia Song, me, myself, Nur Shafiqah and Abdullah Taha. So this is the network system given. Since we are from Group 4, this is the list of specifications. I will straight away open the Idmt software. This is our complete network system. I will be showing you the load flow analysis to determine the maximum current at each feeder. Basically, this is the general circuit of our network system. So this is the parameter given for group 4. All these parameters have been inserted into this system. First thing to do is to do the Idmt analysis by running the load flow to determine the nominal current at each feeder. This can be done by clicking the load flow icon here. So as we can see here, we get the maximum current at each feeder. And I tabulated all the readings in one table. Since we have 13 relays, so this is the total of the load current for the 13 relay. So relay 1 and relay 2 we have 61.2, and then relay 3 and relay 4 we have also the same value, 734.9, and for the relay 5 225.3, relay 6 958.1. Same goes with the relay 8, and for the relay 7 and relay 9 have the same value, which is 513.5. And then for the relay 10 we have 61.2, relay 11 we have 897.7, relay 12 we have 422.3, and relay 13 we have 91.3. I think that's all for the load flow analysis, so I will pass to my next group members.
Assalamu alaikum warahmatullahi wabarakatuh. This is Abdullah Taha from Group 4 and I'm going to talk about the short circuit analysis. As we see here, this is our overall circuit and we have 5 buses, which is bus 1, bus 2, bus 3 and bus 4 and finally bus 5, and we have the total of 13 relays. So to start the short circuit analysis, we open the Idmt software and press the short circuit analysis button as we see here, and choose the 3-phase device duty to determine the values of the maximum fault current at each bus and at each relay. So as we can see here, we inserted the fault at bus 1 to determine the maximum fault current, which was 1.183 kA, and we go through all relays and determine the current at each relay and tabulated the values here at this table. For the bus 2, we inserted the fault as well at the bus and we determined the maximum fault current, which was 14.096 kA as we can see here, and the values of each relays or the current at each relay was tabulated here in this table. For the bus 3, as can be observed, that the maximum fault current at bus 3 is almost the same the maximum fault current at bus 2, which is 14.096 as we can see from here, and all the values of the current at each relay was tabulated here. For the fourth bus, we inserted the fault and determined the maximum fault current, which is 13.516 kA, and the values of relays are written here in this table. And finally, at the last bus, which is bus 5, we inserted the fault and the maximum fault current was, as can be seen here, 12.808 kiloampere, and the value of the currents at each relay are written in this table, as can be observed from here. So finally we summarized all the maximum fault current at each bus, and we tabulated them here as can be seen. So for the bus 1, the maximum fault current was 1.183 kiloampere, and for bus 2 the maximum fault current was 14.096 kiloampere, and the same goes for bus 3, which is 14.096 kiloampere. And for the bus 4, the maximum fault current was 13.516 kiloampere. And finally, for the last bus, which is bus 5, the maximum fault current was 12.808 kiloampere. And that's all for part B.
Good afternoon, everyone. I'm Ko Jasong from Group 4, and I'm going to present Part C and Part D. For the Part C, we need to select transformation ratios of the current transformer CTs and utilizing the class 5P CTs and suitable accuracy limit current. For Part D, I'll do the first part of Part D, which is determine the values of the pickup setting, the PU setting. So after getting the maximum load current from the load flow analysis and also the fault current from the short circuit analysis, we can select the suitable current transformer ratio, CT ratio, by calculating the accuracy limit factor, ALF, and the pickup setting, PU setting. The selected CT ratio need to ensure that the value of ALF do not exceed 20, because in ETAP simulation, we have ALF value of 5, 10, 15, and 20 for the class 5P CT. The value of ALF can be calculated by taking the ratio of the current of the fault to the CT ratio. Other than that, the selected CT ratio also must fulfill the requirement of PU setting, which is below 200%. After selected the CT ratios, the ALF calculated is used to determine the class of the current transformer. ALC is then be calculated by using the multiplication of ALF with the rated current of CT secondary winding, which is 1 ampere. Since relay 1 and 2 have a maximum fault current and maximum load current, we can use the same setting. Relay 1 and 2 have the maximum fault current of 0.312 kA and maximum load current of 61.2 ampere. The CT value that I choose for these two relays are 100 to 1. The ALF can be calculated by using fault current divided by the CT ratio. So by putting the fault current divided by the CT ratios, we can get the ALF of 3.12. So we can put the nearest approximation to 5, which is available in the ETAP. Then the ALC are calculated by using ALF times the rated current, which is 5 times 1, and we will get the 5 ampere. Then the PU setting can be calculated by using maximum load current divided by the CT ratio. So we will get 61.2 divided by 100, and we can get the answer of 0.612, which is approximate to 0.7 PU. To calculate it in percentage, we can multiply the 0.7 times 100% to get 70% of the PU setting. Next, the relay 3 and 4 also can be calculated together since they have the same maximum fault current and load current. The maximum fault current for relay 3 is 5.116 kA and the maximum load current is 734.9 ampere. The CT ratio using for these two relays are 800 to 1. The ALF calculated are 6.395, which then we approximate to 10, which is available in ETAP. Then the ALC are also calculated using the same way, and we will get 10 ampere of ALC. The PU setting we get for this is 0.9186, which we approximate to 1 since the step that we choose for this current transformer is 10. And the PU setting that we get is 100%. Then we calculate all the relays remaining, relay 5, 6, using the same way as relay 1, 2, 3, and 4. Then the calculation will be the same for the relay 7, which will get the CT of 600, LF of 5, LC of 5 ampere, PU setting of 90%. For relay 8, we will get the CT of 1000, LF for 15, LC of 15 ampere, PU of 1, and PU setting of 100%. Then relay 9 we will receive the CT value of 600, LC of 20 ampere, PU percent of 90%, and relay 10 will get CT of 100, LC of 5 ampere, and PU of 70%. The CT ratio chosen for relay 11 is 900, the LC calculated is 10, and the PU setting is 110. For relay 12, the CT are 500, the LC are 5 ampere, and the PU setting is 90%. Relay 13 have the CT value of 100, the LC of 10 ampere, and PU setting of 100%. All the calculated value is then recorded in this table. This table recorded the maximum fault current and the load current of the respective relay. It also recorded the CT ratio chosen for the relay. Other than that, it also have the pickup setting and the accuracy current that are calculated for the respective relay. The class is then chosen based on the calculated accuracy limit current. After getting all the values, we can insert the value into the ETABS. In order to choose the class of the current transformer, we need to change the standard from ANSI to IEC. Then we can insert the classes that we get into the current transformer and also the ratio that we calculated into the current transformer.
Hi everyone, I'm going to explain how to calculate time delta setting for every relay. For pickup setting already explained by the previous presenter. So to get the value of time delta setting, all these formulas are required in the calculation. So we start to calculate the time delta setting of the relay starting from the below. So we start from the relay 10, 11, 12 and 13. For my calculation, I will start from relay 13 and then for PS, we already find before, so we insert the value of RSI, then we proceed to calculate PSM, RCOT by using the formula. Then we assume the value of TSM is 0.1, then we calculate the ROT by multiply the RCOT value and PSM value. Then we get ROT equal to 0.6082 seconds. Then we repeat the step for the relay 12, 11 and 10. By assuming the TSM equal to 0.1. This is because the relay of 10, 11, 12, and 13 at the same level. Then we proceed for relay 9. Relay 9 is connected to relay 12 and relay 13, so we choose relay 12. And then for ROT for relay 9, we insert the delay time plus with ROT of relay 12. And then we find the PSM and RCOT by insert the value into the formula, and we got PSM for relay 9. And then we calculate RSI, PSM and RCOT for relay 9, and we got the new ROT for relay 9. Here we got PSM value more than 20, so we assume a PSM is 20, and then we insert into the formula of RCOT, and then we got ROT. Then for relay 7, we just calculate the directly RSI, PSM and RCOT because the value of ROT is same with relay 9 because relay 7 is directly with relay 9. So the value of ROT is same, no delay time, and we got the value of TSM is 0.08996. Then same goes relay 9, it is directly connected to relay 8, so the value of ROT is same, no delay time, so TSM for relay 6 is 0.1264. And then we continue with relay 5. Relay 5 is connected to relay 7, so we choose relay 7, and then we add the ROT for relay 7 and with delay time 0.4, and we calculate PSM, RCOT, and we got TSM for relay 5. And then we continue calculate RSI, PSM and RCOT, and we got the new ROT for relay 5 by multiply the value of RCOT here and TSM here. And we got ROT is 0.9469. And then the process is repeated with relay 4 by adding the delay time and ROT of relay 5, and then we continue calculate PSM, RCOT, and we got PSM from relay 4, and we continue calculate RSI, PSM, and RCOT to get new ROT by multiply RCOT here and the value of PSM here, and we got ROT. And then for relay 3, the same process, we plus the ROT of relay 5, and then we got TSM 0.4504, and we got ROT is 1.6678. And then for relay 2, is connected to relay 4, and we got TSM is 0.912, and then we calculate RSI, PSM, and RCOT, and we got ROT is 4.208. And then for relay 1, we use the same flow ROT of the relay who is connected with relay 1, which is relay 3, and then we add with time delay, and we got the TSM is 0.912, and then we got ROT is 4.208. And then this is all the PS value and TSM value of all the relay. So how can we edit the setting of the relay? So we just need to change the value of pickup time and time delay here at the setting of the relay, and then we just need to substitute the value of PS and TSM into this column for every relay. That's all for me. Thank you.
Assalamualaikum. My name is Ibrahim Hassan, and I'm going to present part E and F from the assignment. Okay, for first part, we need to produce the time current coordination curve for the relay system. So this is our system. So first we need to click here to the star protection and the coordination, and next we open the star system, so we can find our current time coordination curve. So the vertical line here shows the time in seconds, and horizontal line for current in amperes in our plot. So basically each one of these dots represent one of the relays. So for example, if we click this dot, so it is relay 1, and this is the curve for relay 1, and so for relay 4, so and so on for the other relays. Okay, part F is to see the sequence of the relay operation. So if the fault happens, so you can see, for example, when we have a fault at bus 5, so you can see the sequence of operation of the relays. Now let's open this one. So first the relay to operate is relay 13 after 81.9 seconds, and then relay 10, and so on. So this time basically is the ROT time, real operating time, for each relay. So let's try for fault at bus 2. Okay, first relay 13, and then 10, 5, and last one is 12. So basically the data is collected for each fault at bus 1, bus 2, 3, 4, and 5. So the ROT for each relay will be as shown in the table. Okay, that's all from me. Thank you.